Hello everyone and welcome to my presentation. My name is Sebgawa Alvin Brandon and today I'm incredibly excited to walk you through a project that is very close to my heart, Ecoverse, which is an AI-powered waste management system. So in this presentation, we'll dive into the world of artificial intelligence, exploring some of its core concepts and more importantly, showing you how exactly we are applying those concepts to build a smarter, cleaner and a more sustainable future. This is kind of a deep dive, but I promise you I'll try so hard to keep it very simple and relatable for you guys. So I'll be guiding you through our project, Ecoverse, slide by slide, and explaining how my solution directly uses fundamental principles of artificial intelligence to solve a major real world problem. So let's begin. At, so to understand my project, we need to quickly look at where AI came from. Earlier on, back in the 1950s, AI was about making computers think like us. This was the era of what would maybe refer to as symbolic AI. The idea was to give a computer a very clear set of rules for every particular situation. So let's think of a chess game maybe, where we could program every possible move and maybe counter moves as well. It was about giving a machine the knowledge, like raw knowledge directly. Then in the 1980s, yeah, a bit later on, something very huge changed. AI moved from rules to more of data. We realized that it was too hard to write a rule for everything in the real world. So we started teaching computers to learn everything themselves using a technique which you could refer to as machine learning. Instead of giving the machines a rule book, we would give them huge data sets and let them find patterns on their own. And that brings us to today, our modern world, which is driven by trends like deep learning, which allows incredible features like facial recognition, generative AI, etc. So the focus now is more of using these powerful tools to tackle society's biggest challenges. So where does Ecoverse lie in all of this? So my project Ecoverse is a perfect example of this modern trend. We are using predictive analytics, a form of machine learning, to solve a critical environmental problem. Yeah. So personally, I'm moving beyond the old manual methods of waste management, which are slow and kind of inefficient. And I'm more of reacting to waste after it's been properly disposed of, instead of using data-driven systems to predict where the waste will be generated and to evaluate its potential value. This is a crucial step, especially in promoting sustainable development in places like our own dear country, Uganda. So let's start with problem solving in AI. So at its core, any AI problem is a journey. It's about moving from a starting point to a final goal. We break down this journey using three main concepts. First, you have a state, which is a description of the problem at that particular time. Think of it as maybe your current location on a map. Yes, that's a good example. Next, we have operators. So these are the actions you can take to move from one state to another. These are the roads and the turns you can take to get to your destination that you're looking to get to. And finally, you have a goal, which is the desired end results, where exactly you want to be. So an interesting philosophical challenge related to this is particularly the frame problem. Yeah. So it asks how an AI knows which parts of the problem are important and which can be ignored. So how does waste management AI know that the color of a house doesn't matter, but the number of people living there does? So that's how we can summarize the frame problem. So where does Ecoverse come in the problem solving approach? So now let's apply the framework to our project. In Ecoverse, our problem is to manage waste efficiently. We define our journey like this. So our initial state in this particular situation is a homestead with a mixture of classified waste. Yeah. Our operators are the AI models we built to solve that problem. So these models will predict waste generation and then classify the waste as either valuable or harmful. And our goal is to have the waste at a site accurately classified with the right action, maybe a purchase offer or a penalty in this case. So yes, Ecoverse will locate the waste, and in that particular scenario, the waste is going to be unclassified. So using our AI models, we'll be able to classify that waste as either harmful or valuable. And in this case, fines will be imposed. Yeah, if the waste is not valuable, and if it's valuable, yes, it will be taken for recycling. So this simple structure helps our system to think clearly and transparently about waste, allowing us to build a predictable and reliable service. So let's talk about problem solving by search. So since AI problems are all about a journey, we need algorithms or steps to help the AI find the best path. These are called search algorithms in this particular case. There are two main types of search algorithms, and the first one being uninformed searches, which are normally known as blind searches. They don't know where the goal is, so they just explore all options until they find the goal. So a good example is a breadth first search, which explores every nearby option before moving further away from it. Then you have informed searches as a second type, which are more of smart in this particular situation. So they use a heuristic, which is a smart guess or a rule of thumb, to guide them towards the goal more efficiently. An example being the S search, which is like using a GPS to choose the fastest route to your destination. And let's not leave out the simulation argument, which also comes in handy in this particular situation, by asking if our reality is actually a simulation. It relates to search. It relates to search because an AI is essentially simulating different paths to find the most optimal one. Yes. So in Ecoverse, we use the idea of a heuristic search to optimize our waste collection. Our system doesn't search randomly for waste. It uses smart guesses to firstly maybe prioritize the sites where we expect to find a lot of valuable recyclables. For example, a business, yeah, maybe a homestead. And secondly, it identifies high risk areas with a history of improper disposal, such as homesteads near public places, yeah, and those harmful businesses as well. This helps send our teams to the right places and at the right time, saving both time and money in this particular situation. So, how does an AI know what a plastic bottle is or improper disposal means? Yeah. So, we have to teach it, and this is called knowledge representation. We use formal languages to store facts and rules that the AI can understand. A powerful tool for this is what we refer to as first order logic, or FOL, FOL in this case. So it uses symbols and rules to express relationships. But one philosophical challenge in this case, however, are the limits of formalization. Just like any other procedure, formalization also has its own limits. Yeah, whereby we can represent a lot of factual knowledge with rules, but things like common sense or intuition, yeah, are very hard to put into formal language, of course. But in Ecoverse, we use clear logical rules to classify waste and guide our actions. Yeah. This is the simplified form of first order logic in this case. For example, our rules might state if a method waste type is PET plastic or construction remains, yeah, and the quantity is more than 5 kilograms, then its value is high. Yeah. In this case, high we mean purchasable. Yeah. So if a waste type is medical waste and it's found in an open dumping spot, then automatically it's tagged harmful. Yeah, and therefore a penalty is awarded in that case. So these are simple rules. Yeah. And these rules are the brain of our system, allowing it to make quick automated decisions based on the data it receives. Yeah. So in Ecoverse, yeah, our system uses inference as well to make a final decision based on the rules we've given it. Here's a simple example you can follow. So let's say a drone observes a homestead or a business, yeah, and gathers three facts. observed waste, which is maybe scrap metal or construction remains or polythenes, yeah. And its quantity being maybe 15 kilograms, and the local market price maybe 600 shillings per kilogram. Um, there, there and then our system then applies a rule we gave it, which was if the waste is scrap metal and its quantity is greater than 10 kilograms and its price is also greater than 500 shillings per kilogram, then using the inference method, it's offered for purchase in this particular case. So because all the conditions of the rule are met, the system then makes a deduction that this site is worth a purchase offer and not a punishment, which is the other option. So this helps us to automate decisions quickly and more accurately. So let's talk about reasoning and uncertainty. Yeah. So in the real world, data is often incomplete or messy. Yeah. But we need a way to deal with uncertainty of data as well. So things like probabilistic models, yeah, they can use mathematics to handle this. The most important concept here is the Bayesian reasoning, yeah, which is a technique that updates the probability of an idea as new evidence comes in. We start with an educated guess and then refine it with new information. The philosophical question remains, can we really put a number on a gut feeling or on human intuition? Yeah, so that's a challenge that pushes the limits of AI, of course. So let's talk about Ecoverse and unpredictable data. Yeah. So as you all know, waste data can really be very unpredictable. That's why Ecoverse uses the Bayesian reasoning to make robust predictions. Yeah. When you're trying to predict whether waste will be generated, we use prior knowledge. For example, average plastic use in a neighborhood in Kampala. Yeah, we can take an example of that. So we then update that with new evidence, such as number of people living in that household or in that particular area. So this helps our system make good decisions, even if the data is not perfect in this particular case. That leads us to planning, yeah, which is maybe in short, which are the steps to reach a goal in this case. So planning is about figuring out a sequence of actions to reach our specific goal or destination. It's like writing a to-do list, yeah, for a robot or an AI model. So every plan has three things. Firstly, there's an initial state, like we understood earlier, where we start from. Then a goal, and lastly, the set of actions we take to reach a particular goal. Let's take a look back to the frame problem. Yeah, which pops up here again. As AI needs to know what and what change after you perform an action. So if you pick up a plastic bottle, the price of that plastic will stay the same in the AI model system. So let's talk about how Ecoverse uses planning. Yeah, how Ecoverse uses this particular route plan. So Ecoverse uses planning to optimize waste collection and inspect logistics, which is a huge deal for efficiency and in a busy city like, let's say, Kampala. So our goal is simple. Yeah, we efficiently collect valuable waste and inspect high risk sites. Yeah, that's what Ecoverse does. So our system creates a plan that maps out the best route for a collection truck. It considers all the stops and orders them to minimize travel time and fuel consumption. This saves money and also helps the environment in the long run. So this leads us to our next section, which is planning and decision making. So when an AI is planning, it doesn't just want to find out the path; it wants to find the best path for solving a particular problem. So this involves making smart decisions by thinking about one, the utility, how good and desirable the outcome is, then the risk in the outcome as well. But the philosophical question in this particular situation is whether an AI is really being smart when making each decision, or is it just being very fast at calculations of probabilities and maybe the utilities? Yeah. And of course, just like we've been doing in the other section, we talk about Ecoverse and this particular idea of smart decision. So Ecoverse, like I've already explained, it doesn't just make a decision, but it makes an optimal decision by weighing all the different factors in this particular problem. So yeah, when classifying waste, my system evaluates firstly the economic value of that waste, like how much money can we make from recycling that material. Yeah. Then the environmental value of that waste. Yeah, like how much is pollution being prevented in this case, and also the operational costs. Yes, like how much will it cost, yeah, to collect the waste after it's been located. So this approach ensures that every decision Ecovas makes is sustainable and profitable for a region like Uganda or maybe a small region like Kampala. Yeah. Yeah. So this leads us to section 9, which is machine learning. Yeah. And machine learning is the most common way to build AI today. It lets computers learn from data without being explicitly told what to do. So there are two main types of machine learning. The first one being supervised learning. Um, and in supervised learning, the AI learns from labeled data. For example, it's like having photos of maybe cats, dogs, but labeled cat and dog respectively. The model learns to associate the image with the label itself. Yeah, that's supervised learning. And unsupervised learning is where AI finds the patterns itself in unlabeled data. So it's like grouping similar customers together without being told what the groups are. Yeah. So one interesting debate via machine learning is whether AI can ever become superhuman. Since machine learning models can now outperform humans in tasks like chess, medical diagnosis, yeah, and other areas as well. So let's talk about Ecoverse's core machine learning models. So firstly, like we've already understood, Ecoverse relies on machine learning for most of its features. And firstly, for predicting waste, we use supervised learning. Yeah. So we learn on maybe historical data, for example, the neighborhood size, the population. Yeah, we use that historical data to forecast how much waste will be generated in those areas. Then for classifying the waste, we use supervised classification models. These models are trained on data sets where waste items are labeled as either harmful or valuable. And yeah, I think this is the true power of Ecoverse because it automates decisions by learning from past data, ensuring efficient and sustainable waste management. Yeah. So this brings me to a conclusion. Yeah. And I think I can happily conclude that Ecoverse is a powerful example of how AI can transform a complex real world yeah, problems, and this particular problem being waste management in this case. So by using predictive models, we are moving from simply reacting to waste to actively anticipating and managing it. Yeah. So our system doesn't just manage waste; it identifies and creates both economic and environmental value, turning a problem into a sustainable opportunity for communities. The future of waste management in Uganda and in other areas lies beyond of course lies beyond smart driven solutions like Ecoverse. Yeah. And a final word to my dear viewers, I would like to share my certificate for my work in this course. Yeah, and this certificate helped me to lay a foundation for my project Ecoverse. And honestly, thank you so much for your time today. It has been a pleasure sharing my project with you and all these wonderful ideas. And kindly, if you have any questions, please, yeah, submit them in the comment section and I'll be happy to answer them. Now, thank you so much.